Yeah, so good evening everyone. Good evening. I hope audio video is okay. Yeah, please check once. This is the place where we stopped yesterday. This is the place where we stopped yesterday. I feel so. Right? Yeah, I think we can start now. I think today's date is 13, I think so. Today's date is 13. So let me write here 13, 8, 13, 8. Oh no, what is the issue? Let me check once. Let me know audio video is okay or not. Some issue there. Some issue there. Just give me a minute. Hope it will resolve now. Yeah, perfect. So today's date is 13/8/26. This is the today's date. Yeah, we can start now. All the things which are required we are already covered. Right? We are already covered the things which are required. Right? Now take care. Right? Now I'm starting. Everything is fine. About the planar graph, yesterday we started. Right, so two formulas also I given. Now I am saying one important thing. Can you listen, everyone? Everyone listen. Everyone listen. Yesterday we stopped here. So today's date I written. Now I want to say one small thing. Please listen, everyone. Please listen, everyone. K15. K15 is planar. So one here, 5 people. No edge crossing, this is a planar. 2 here, 3 here, 4 here, 5 here, 6 here. It's a planar, no issue. Next one, K2, K2, 5. K2, 5. If you want, you can verify K2, 5. It is also planar. 1, 2 here, right? 3, 4, 5, 6, 7. So if you want to check, it is a planar. Right? So this one you can easily keep on write like this. No issue. Like this you can keep on go. So it is also planar. K to 5 also planar. But understand everyone. What about K33? Understand what about K33? See this one? 1, 2, 3, 4, 5, 6. Everyone observe. 1, 2, 3, 4, 5, 6. Like this. Right? Next one. I think 2 there you can manage like this. But what about him? You can do like this, okay? You can do like this also, okay? But how to cover this person, how? Guarantee edge crossing there. You go outside, edge crossing. You go inside, edge crossing. Compulsory edge crossing there. Compulsory edge crossing. You go like this, edge crossing. Right? You go from outside. Let me go from outside. Edge crossing. Or edge crossing. Yeah, this is the thing. So you can come from outside. Let me try from outside. Right, like this. Edge crossing compulsory, that white color. So K33 is non-planar. K33 is non-planar. K15 is K15 is planar. K25 also planar. K33 is non-planar. Right? So K33 is non-planar. Let me go for one more. Let me go for one more. Just wait. Let me go for one more. One more thing, let me go. Some people are saying, what exactly, sir? If you want, you can verify. K3 is planar. K4 also planar. Verify. We done yesterday also. But let's try K5. Let's try K5. A, B, C, D, E. A, B, C, D. A, B, C, D. Let's see this. K5. We are talking about K5. In the K5, everyone is adjacent to everyone, right? I think this is okay. This one okay. This is also okay. Fine. But what about, right? Let me use another color. Let me use another color. If I want to cover these two, here problem is coming. If I want to cover this, if I come like this, here there is a problem. Or here also there. If you go outside, here a problem will come. So it is also non-planar. It is also non-planar. So if you observe clearly, Arpit is saying thanks for this much effort. Thank you, Arpit. Thank you so much. So if you observe clearly, listen everyone. Note, note. K, careful. K33 non-planar. K33 is non-planar, and one more. It is going to be non-planar. K34 also non-planar. K, right? And one more thing is 3, 5 also non-planar. So non-planar will start from K33. But remember K, everyone observe K 200. 2 comma 100. It is planar. K2 comma 100. It is going to be planar. It is planar. If you want, you can check. If you want, you can check us, right? So one person all will go inside, one person all will go outside. It is planar. K, see this one. 3, otherwise I can write this K 4 comma 10, non-planar. So if you observe clearly, carefully, K m comma n is non-planar. K m comma n is non-planar, right? Where m is greater than or equal to 3 and end operator. N is greater than or equal to 3. Either both are 3 or more. It's the end operator. Remember, end operators should be satisfied. Right? M should be 3 or more than 3, and n should be 3 or more than 3. One person is less than 3, one person less than 3, other person is more than 3, no issue. See this. One person is less than 3, other person is more than 3, then it is a planar. Right? Both should be 3 or more than 3. Both are 3 also non-planar. K, M, and E is non-planar where M is greater than or equal to 3, N is greater than or equal to 3. So careful, this is a very, very important note. Next, one more note I want to say, listen carefully too. Careful. K4 is going to be planar. Right? Next one, K5 is non-planar. K6 is a non-planar, and so on. So conclusion is Kn is non-planar where n is greater than or equal to 5 or more than 5. These two notes, please careful. It's a very, very important notes. These two are very, very important notes. Non-planarity will start from K33 or K5. Non-planarity will start from K33 or K5. Non-planarity will start from here. Right? Observe everyone. Non-planarity will start from here. I hope everyone fine. Non-planarity formulas, remember two formulas. Connected graph, right? Connected graph, planar. This is the one formula, right? So this is the connected graph. Connected graph, this is the formula. So right, connected may not be anything. Anything. If it is a planar, it will work. This may work for connected also, disconnected also, but this will work for only connected. This right, this will work for only connected planar graph. This will work for every planar graph, right? So please take care about this formula. And one more, sum of degrees of regions theorem. Sum of degrees of regions theorem, that also take care, right? And one more, non-planarity will start from K33 and K5. K5 complete graph with 3 partition, right? So complete graph with 5 vertices, right? From there onwards, non-planarity will start. Condition also I written Kmn is non-planar where m greater than or equal to 3 and n greater than or equal to 3. K5 is non-planar, sorry, Kn is non-planar where n is greater than or equal to 5. I hope everyone is comfortable. I hope everyone is comfortable. Now come to the next story. I will give one problem. Let's see how it is going to be. Right? How it is going to be. So let's see this. It's going to be very interesting problem. Example. One example. It is there in the previous papers. Let's check. Let G be a non-planar graph. Non-planar graph. Let G be a non-planar graph with minimum number of edges. With minimum number of edges. Let G be a non-planar graph with minimum number of edges. Then G should have. Let G be a non-planar graph with minimum number of edges. Then G should have option A, B, C, D. 9 vertices, 9 edges. 9 vertices, 9 edges. Then G should have 9 vertices, 9 edges. 6 vertices, 9 edges. Next one, 5 vertices, 10 edges. Next one, 3 vertices, 5 edges. Let G be a non-planar graph with minimum number of edges. Then G should have 9 vertices, 9 edges, 6 vertices, 9 edges, 5 vertices, 10 edges, 3 vertices, 5 edges. So please careful. Right? Try. Sir, I have completed the graph theory with previous lectures. Should I have to watch this also or same content is there? Yeah, same content. You no need to watch. Right? Please go and complete the remaining. Thank you so much for asking. Right? No need. So same content only there. So what is the answer for this? Thank you so much, engineer, for asking. Let G be a non-planar graph with a minimum number. Let G be a non-planar graph with a minimum number of edges. Then G should have. Which one is right? Remember, non-planarity will start from. Non-planarity will start from. You know very well. It will start from either K5 or K33. Non-planarity will start from either K5 or K33. But remember, K5 contain 5 vertices. And one more, how many edges? 5 into 4 by 2. 20 by 2, 10. 10 edges. It is a one combination. One more. Here, 6 vertices. And the edges are 9 edges. So which one is correct? Check. 6 vertices, 9 edges is one. Right? And one more is asking minimum number of edges. You want minimum edges. Edges here 9. Here 10. I think this is 6 vertices, 9 edges. I think B is the answer. Check. If at all minimum number of vertices, it could have been It could have been 5 vertices, 10 edges. C is the answer. Minimum number of edges, then answer is B. Minimum number of vertices, then answer is C. So careful. Non-planarity will start from K5 or K33. K5 or K33. Right? Any objection, any small doubt, let me know. Sir, I have this doubt, sir. You ask me, I will help. Ready, sir? I have some small doubts, sir. You ask me, I will help. Non-planarity will start from either K5 or K33. Right? Let me check. Let me check one small line. Let me check one small line. I am going to give one more note also. Please listen, everyone. Please listen, everyone. I am going to give one note also. Right? That note is very valuable note. That note is very valuable note. Please understand. Understand, everyone. Understand, everyone. Everyone understand. Everyone understand. A. It's a very useful note to you. A, B, C, D, E. This note is very important. This is everyone know K5. This is K5, which is non-planar. Everyone know this. Right? This is a K5, which is non-planar. Everyone know. Now understand. Understand, everyone. A, B, C, D, E. One important point I want to say, just listen this also. It is K5. It's a K5, that's okay. It is a non-planar, that is also okay. But remember everyone. A, B, C, D, E, it may be F, it may be G, maybe H, I, J, K, J. Just I am giving roughly. L and M and M and M. Don't confuse. Just I am giving something, nothing. Don't confuse. Now, can you help me? Can you help me? In the given graph, is there any subgraph which is K5? It is a one graph. That's okay. This is a one graph. Assume this is a graph G. It is a some graph G which contains subgraph S. Otherwise, I will say, this may be subgraph. I think I can say it the G1. I will say it the G2. G1 contains subgraph G2 or not, which is non-planar. G1 contains subgraph G2 or not, which is K5. I think if you observe clearly, I could have written another color. I will write now also. See, it is K5. G1 contains subgraph which is G2, which is K5, which is non-planar. So this is also non-planar. Any graph which contains subgraph K5 or K33. If any graph contains subgraph which is K33 or K5, then that graph also non-planar. If you find a graph in which there is a subgraph which is K5 or K33, right? Then the given graph is non-planar. Directly K5 non-planar. A subgraph which is K5 non-planar. A subgraph which is K33 non-planar. So observe, right? Be careful. And one more thing I want to clarify, right? Please listen. Please listen, everyone. Please listen. So this diagram K5 is there. See, so this diagram K5 is there. Please observe. I am adding some more vertices in between. Carefully. These circles are vertices, assume. So if you observe clearly, these circles are vertices. I think in the subgraph, if you observe, there are so many vertices are there, so many edges also there. But if you see the structure, it is exactly like K5. The yellow color, red color, the yellow color, and I think that may be red color. I don't know, right? The other than white color, whatever I written. If you observe clearly, structure is like K5. But in between maybe, right, one edge is divided into two edges, right? One edge is divided into four edges, right? In a path, right? In a particular edge, so many vertices are added. So remember, right? This part, whatever, assume this subgraph. I'm talking about this subgraph. This subgraph and this graph, they both are this graph and this subgraph. These two are homomorphic to each other. Homomorphic in the sense same behavior. See, same appearance. The only thing is one edge you made it as two edges. One edge you made it as three edges. One edge you may make 10 edges. Means you are dividing the edge into some more edges. Right? So remember that subgraph and the K5 both are homomorphic to each other. So what is the meaning of homomorphic to each other? Let me check. Let me check everyone. Let me check everyone. Everyone observe. A, B, C, D. Same appearance. Right? In terms of the appearance, both are same. The only thing is one edge maybe become more edges. Assume this is one graph, it is a K4. Now I will write one more homomorphic graph. Can you see this? One more homomorphic graph I will write. It's a K4. One more homomorphic graph I am writing. This is also K4. Careful. This is also homomorphic. For the G1, G2 also homomorphic. Exactly same. That is also homomorphic. Exactly not same. One edge divided into three edges. But appearance is same. See, same design, same behavior, everything same. Maybe vertices are more, maybe edges are more, but right, if you see the physical view, almost same. Right? Then I can say those two graphs are homomorphic to each other. One edge you are making, maybe five edges also. Right? So, right, one edge maybe you are making four edges also. Right? It may be two edges. So remember graph 1, graph 2 are homomorphic to each other because same appearance. Right? Now if you are comfortable, I am going to write one important note. Can you see the one important note, everyone? Right? Note I am writing. This is the very, very important one. This is the very, very important one. Please listen, everyone. In a given graph, in a given graph, or in the given graph, in the given graph, if you found any subgraph in the given graph, if you found any subgraph which is any subgraph which is homomorphic to K33 or K5, then given graph is non-planar. It's very, very important. In the given graph, if you found any subgraph which is homomorphic to K33 or K5, then given graph is non-planar graph. It's a very, very important note. This point is very, very important. If you in the given graph, if you find a subgraph which is homomorphic to K33 K5. K33 K5. Homomorphic, right? Homomorphic in the sense what? Exactly same. Or one edge you made it as, right? Three edges, two edges, four edges, right? So same only, everything same, but the edges are divided. Edges are divided by adding new vertices. Then I can say those two graphs are isomorphic to each other. Right, fine. This is a very important one. Maybe I will try to find out if at all we have any good example. Let's check. Let's check. Yeah. Can you go to the next problem? Find 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 or check following graphs are planar or not. Check following graphs are planar or non-planar. Check following graphs are planar or non-planar. Right? I am writing some diagrams. I am writing some diagrams. A, B, C, next one D, E, F, which will goes to, I think, let me write here. It is a one graph, assume G1. Next, A, B, C, D, A, B, C, D. Next one, E and F, G and H. So let me write here. I think this, yeah, the G2 and one more. A, B, C, D, E, F. Yeah, it's a K6, I think. It is a K6, right? Let's check. It's a K6. So, in the given three graphs, which are planar, which are non-planar, find out. It is a G3. Please identify. Check following graphs are planar or non-planar. Can you try? Check following graphs are planar or non-planar. Please verify. Make it fast. Make it fast. Check following graphs are planar or non-planar. Can you draw the same graph without edge crossing? Can you draw the same graph without edge crossing? I think everyone know. This is K33. This is K33. Everyone know. It is non-planar. Everyone know it is a K6. It is a non-planar. It is non-planar. It is also non-planar. Everyone know because they are homomorphic too. Not only homomorphic, it is exactly same. Right? I think if you observe clearly, K5 itself is non-planar more than K5 compulsory. It's a non-planar. K33 is non-planar. Exactly K33 is given non-planar. So the third diagram, if you see, is a K6. K5 itself is non-planar. Definitely more than K5 is going to be non-planar. So let's see what about this. Is it non-planar or not? Right? This diagram is non-planar or not? Let me check. Let me check once. Yeah, I think this is having some issue. Just give me a minute. Just give me a minute. Yeah. Yeah, fine, perfect. So this is what about G2? What about G2? Let's check once. A, can you draw the same graph without edge crossing? A, B, C, D. Next one. E, F, or otherwise, yeah, I will change the names. Let me give as it is names. A, B, C, D, and E, F, G, H. So like this. So I will try without edge crossing. I will try without edge crossing. I think that's like this, like this, like this, like this. It's perfect till now. It's still now perfect. This is also okay. This is also okay. This is also okay. This is also fine. Hmm? This is also fine. I think if I want to write like this, it is problem. If I want to write like this, it is having issue. Hmm? I think this don't have any issue. I think two things are creating problem. Remaining all are okay. Two things are creating problem. Remaining all okay. Then what you do is, I think this person maybe we can write from outside. A B. It is a C. It is a D, right? D I am writing outside. It is the E. It is the F. Right now, I think this edge which is going, I can write from outside. This edge which is creating, I can write from outside. Please verify if I done anything wrong. This is also okay. See this. With the D, three edges are there. Those two people are creating problem. So I drawn from outside. So G2 is planar. G2 is planar. Check one time. Check following graphs are planar or non-planar. Check the following graphs are planar or non-planar. Verify. G2 is planar, right? G3 is non-planar. G1 is non-planar because G1 is exactly K33. Exactly means homomorphic also. So G1 is homomorphic to K33. So it is non-planar. If you see the G3, K5 itself is non-planar. It is more than K5. It is a K6. It is a K6. Right? It's a non-planar. So G2 is planar. Right? Perfect. Perfect. Everyone got to know what is happening. Right? I think this problem also people are really comfortable. People are really comfortable this problem also. Now I will try one problem. Right? I feel it is the correct time to give that. I will give one problem now. Right? Can you listen everyone? Can you listen everyone? I'm going to give one problem. On planar graph, I'm going to give one problem. Check one time. Check one time. Yeah. In a in a simple connected connected planar graph, in a simple connected planar graph with 20 vertices, each of degree 3, then find Then find number of regions. Number of regions. This is a problem. In a simple connected planar graph with 20 vertices, each of degree 3, 20 vertices, each of degree 3. Then find number of regions. Yeah, can you go and give the answer for this problem? Try everyone. Make it fast. In a simple connected planar graph with 20 vertices, each of degree 3, then find number of regions. 20 vertices, each of degree 3. Be careful. First of all, it is a simple graph and a connected graph, planar graph, right? Understand all the things whatever is saying. It is a connected graph. It is a simple graph. It is a planar graph. Be careful. All keywords are very, very important. Right? And one more. 20 vertices each of degree 3. 20 vertices each of degree 3. Can you see this one? Can you see everyone? 20 vertices each of degree 3. So what is it? 3 plus 3 plus 3 plus and so on. 3, 20 times. Right? I think it is going to be sum of degrees. Sum of degrees. Sum of degrees is equal to 2 into E. Sum of degrees is equal to 2 into E. I think it's going to be 20 into 3. Is going to be 2 into E. Right? I think E value if you observe, right? 2 and 20 will be cancelled. So 10 into 3, which is 30. Number of edges are 30. Number of vertices already 20. And a simple connected graph. What is the answer? V plus R is equal to E plus 2. You know this very well. If it is a simple connected planar graph, this formula will work out. So we already given 20, right? R we have to find out, right? So E value now only I calculated 30. So finally R is equal to 30 plus 2 minus 20, which will goes to 10 plus 2, which is 12. Right? I hope everyone is clear. Check one time if you have doubt. Reddy sir, I have some issue. Right? Please let me. Please let me know if you have issue. In a simple connected planar graph with 20 vertices, each of degree 3, then find number of regions. Then find number of regions. These many regions are there. I hope everyone is okay. Let me know if you have any objection. Sir, I have some doubts, sir. You ask me, I will help you. You ask me, I will help you. Yes, can I move to next? Can I move to next? Right? Can I move to next? Yeah, I think one more problem is there. We'll do that also. Right? One more problem is there. We'll do that also. Can I go to the next? So many people are asking, sir, what is so special with the EPT? This is examination oriented. EPT purpose is examination oriented. We don't teach anything unnecessarily. Right? Examination oriented up to the mark. So all classes are in English. No Hindi, no Telugu, no Tamil, no Bengali, nothing. It's a purely English only because it's a computer science. All jobs are based on the English only. Total software industry running on English only. If you are not comfortable, please practice. Sir, I am not comfortable in English. Then practice. So all lectures will be in English only. Right? Live and recorded is possible. Right? Daily quizzes also there. Doubt solving is there. EYQs are there. Assignments also available. Right? Next one is guidance is there. Every Saturday, Sunday we will give targets. Every Saturday, Sunday we will give targets. Mentorship sessions also there. Right? We don't ask you to prepare blindly. We will give targets and we'll ask you please prepare. Next one, these are the last year toppers. From EPT, these are the last year toppers. I wish next year I will see your photo also here. And one more thing is, right, last year for 200 students, we are giving the free education last year. This year, I want to give 1,000 students freely. 1,000 students, I want to give free education. Not 1 to 1,000 students, I want to give free education. The only thing is, you should be in a class top 5. In your class, you should be in the top 5. You are studying in the college, you are there in the college, right, in your class, top 5 position. Right, either first, second, or third. If you are in top 5, you are eligible to this. We will give free of cost. We will give free of cost any course, whatever course you will ask, we will give. Is it placement course, GATE course, right? PSU's course, whatever course you want, we will give freely. If the only thing is, you should be in top 5, right? Send mail. If you are in top 5, send mail from your college mail ID, right? So your HOD or principal or college management should send one mail, right? So and so student is there in the top 5 of the class, right? So please give chance to him in the EPT Rise 1,000 initiative. Then we will give almost free cost, right? The only thing is, you have to pay minimal cost to 2,000 for the platform fee. Platform fee, you have to pay just 2,000 rupees. Total course we will give freely. Just send mail if you are in the top 5. I want to give 1,000 students free. Many people are taken this. Many students who are the topper, they are taken already this one. If you are also in the top 5 or your friends are there in the top 5, please you can send them. If you are preparing for GATE or placement, we are going to give, right? So free of cost. Free of cost, we are going to give course. Next one. So live class is, I think, evening is going on, Discrete Mathematics for GATE CSE exam. Right. Next one is RIC course going on for all these branches. For all these branches, aptitude is going on. RIC batch started. New RIC batch. First subject is right. Aptitude is starting. 8:30. It's going on now. It's going on. Next one, early morning data structure for GATE CSE, GATE DA, and placements. 6 a.m. onwards it is going on. And one more important thing is, right, mock test is going to be happen 15th of August. 15th of August, mock test is going to be happen, engineering mathematics. I request please start attempting mock tests. I request everyone, please start attempting mock tests. It's my sincere suggestion to all the people, please start attempting mock tests. Right, fine. Next, C programming is freely available on YouTube in the EPT platform. EPT platform also freely available. YouTube, exam prep tool YouTube channel also freely available. Utilize. Python programming also in the YouTube also available. EPT platform also available. Please utilize. Discrete mathematics, right? And the EPT also available, right? And YouTube channel also available freely. Please utilize. It's my request. Please utilize these three: DA people Python, CSE people GATE, right? C programming and discrete mathematics. So you can buy whatever course you like. Premium courses you can buy, right? You will get the many advantages, many features will be there. Live classes, premium classes, you will get the live classes, test series, rank improvement course, which is very important to you, right? So 3,500 questions with very good video solution, expected questions, and test series, 1,000 tests, 100 tests will be there, subject wise, topic wise, mixed subjects, right? All are there. And mock tests also there, 25 mock tests will be there. And one more thing is mentorship is there. Every weekend we will give the targets also. Many free resources are there. Validity, you can buy premium courses 1 year, 2 year. And one more thing is 6 months course also there. You can take whatever you want. Affordable courses, if at all money issue is there, you can go for financial issue, you can go for affordable courses, right? So I know very well, right? Many students are having some financial issues. I also have, whenever I am student, I also having so many issues. I face a lot of difficulty. I thought same thing happening for students also, so we started the affordable courses. You will get the many advantages except few things. RIC course not there, test series not there, mock tests are not there, right? You will get the all the lectures, recorded lectures, all you will get very minimal price, very minimal price. 1 year course also there, 2 year also there, 6 months also there. Please utilize. some free subjects also there, free courses, you can utilize them. Test series also there, mentorship also there. And one more thing is GATE plus PSUs. And one more thing is GATE plus placements also. GATE plus placements also. Right? You join whatever course you like. Very minimal prices are there. Affordable prices are there. Don't buy courses of right 30,000, 40,000, 50,000. Please don't buy. Not needed. Not needed. Everything is coming with very less cost. Why you buy unnecessarily? Don't waste money. Don't waste mama papa money. If you really need money problem is there. You can go affordable. Suppose money problem is not there, go to premium. They are also very less cost. You can check. Right, next one. So assignments also available. Best assignments are available. Offers notes also available. Previous year questions also available. Doubt solving also there. Mentorship sessions also available. Please utilize. Next one, right? So these are the people who placed in the big MNCs, Google, Microsoft, right? Google, Microsoft, Qualcomm, Meta, big companies are placed using our EPT placement course, DSA course, DSA plus system design, DSA practice courses, interview course, programming languages course, development courses. But however, two languages are free, they are in the YouTube, you can check. So you can use this code. One offer is going on, 70% offer going on, 70%. Recently changed because of right, because of Independence Day, 60% became 70%. You can utilize. You can utilize. Right. Come to the next. Come to the next. I am giving one more problem. Please check. One more problem I am giving. Please verify. So what is that problem? Let's check here. Let G be a simple connected planar graph with 10 vertices. If the number of edges in each face means region, is 3. If the number of edges in each region or each face is 3, then find the number of edges. Yeah, can you go ahead this problem also? Let G be a simple connected planar graph with 10 vertices. If the number of edges in each face is 3, face means region, then find the number of edges. Please go ahead. Whatever information is given, please write first. Vertices are 10. Okay. If the number of edges in each face is 3, so degree of each region, let me write degree of each region equal to 3. That is the thing. One more thing is given. How many vertices are given? How many vertices are there is not given, but degree of each region is 3 is given. And is asking number of edges how many? I think 10 vertices is given. No? Sorry for that. 10 vertices already given. Sorry for that. And degree of each region also is given. That is also okay. But number of edges is asking. Please find. Number of edges. Please find. Yeah. Try. What can be the answer? We don't know how many regions are there. But degree of each region, degree of each region is 3. Let us assume regions are, number of regions are Let us assume number of regions is equal to 3. Vertices 10. Degree of each region 3. Let us assume number of regions are R. Right? How many edges are there? He is asking. How many edges? Right? Now, what we should do? Can you help me? So if R regions are there, sum of degrees of region is equal to 2e. So I think the sum of degrees of region, if you observe, 3 plus 3 plus 3, 3. I think R regions are there is equal to 2e. That is a formula. Sum of degrees of regions. Sum of degrees of regions. Right? So I think 3 plus 3 plus R regions are there. This is equal to, which is nothing but 3R is equal to 2E. But we want E, we want E. So which will goes to E is equal to 3R by 2. Keep it first. But we don't know R, Yeah, I think anything is okay. I think let me find out R. Whatever you want, you can do. Let me find out R. R is equal to 2E by 3. R is equal to 2E by 3. So I calculated R value. And one more thing is, it is simple. It is a simple connected planar graph. Simple connected planar graph. So you know formula. Right? V plus R is equal to E plus 2. This is the formula. Right? So V is 10, you know. R is going to be 2E by 3. That is also, you know. So E plus 2. Right? E plus 2. Now let's send all the e's one side. Then it is going to be 2 will come this side. 2e by 3 will go that side. It's going to be 10 minus 2 is equal to E minus 2e by 3. Right? It is going to be 8. 8 is equal to 3e minus 2e by 3. Right? Which will goes to 8 is equal to E by 3. Finally, E is equal to 24. I think that is the answer. Right? Check once. One time check. Is it okay? Is it okay? Please verify. Let G be a simple connected planar graph with 10 vertices. If the number of edges in each face is 3, then find number of edges. I think this is the answer for this. Right. Planar graph, we done, I think, many problems. Most expected question is from planar graph. Most expected question will be there from planar graph. Right? I think you are perfect. Now, one small question, I think, is very simple. It's a very simple, very small question is there. One small question is there. So I will try that problem also. Right? One small. Find, very simple. Find number of simple graphs. Find number of simple graphs possible with n vertices. Find number of simple graphs possible with n vertices. That is a problem. Find number of simple graphs possible with n vertices. Right? So let's try to give answer what exactly it is. Find number of simple graphs possible with n vertices. Right? I will try. Small story. I will try. N is equal to 3 vertices. N is equal to 3 vertices. Assume 3 vertices are A, B, C. With A, B, C, with 3 vertices, how many simple graphs possible? I will try. First of all, with N is equal to 3 means A, B, C, how many simple graphs possible? If you want to know, first of all, find out how many maximum edges are there. Right? N is equal to 3 ABC. How many simple graphs possible? That is a question here. So I am trying to find out one by one. The first thing is going to be first thing, because of the simple graph. Simple graph. First find out maximum degree how much. Maximum degree possible how much. Three vertices are na? Three vertices, right? Maximum degree possible for any vertex. For any vertex, because it is simple graph, is equal to 2. Three vertices, maximum degree possible is 2. That is the first thing. Okay. It's 2. Next, 2. If you want to give answer for this problem, first thing is maximum degree possible for any vertex, how much find out? 2. Next one. Maximum edges, how many possible? Check. Maximum edges possible is equal to what is the answer? I think maximum edges means 3 vertices. Na? Maximum edges means number of edges in K3. 3 vertex complete graph. Then I think everyone know formula. 3 into 2 by 2. 2 cancel 3. 3 edges. Maximum edges possible is 3 edges. To give the answer for this problem, first you have to calculate maximum degree possible for any vertex. Simple graph with 3 vertices, maximum degree possible is 2. Next one, maximum edges, how many possible? I think 3 vertices, maximum edges. I think complete graph. Complete graph, how many edges? 3 into 2 by 2. So 3 edges. I think fine. Now if you okay, I think why some people are asking, why are you calculating everything maximum? Why are you calculating everything maximum? What is the reason? I want number of simple graphs possible with n vertices. Means all possible simple graphs I want. Means all possible simple graph. All means maximum possible simple graphs I have to draw. So these are the information which required. Maximum degree find out using that. Right? Maximum edges, how many possible find out? I think 3 edges. Let us assume those 3 edges are assumed E1, E2, E3. Assume those 3 edges are E1, E2, E3. So I think those edges may be this. This is the E1 edge. It is the E2 edge. It is the E3 edge. First find out maximum edges. Right? I think 3 edges. 3 edges give labels also. Yes. Now how many possible? First one, all 3 edges don't take. Out of 3 edges, don't take anything. This is one simple graph possible. No edge there. Next, first edge there, second two not there. Second edge there, first one, last one not there. First and second not there, third there with one edge. With one edge, 3 simple graphs possible. A, B, C. A, B, C. A, B, C. A, B, C. Right? Fine. That is a one more. One more thing is going to be 1 1 0 0 1 1 1 0 1 2 edges 3 possible. 2 edges 3 possible. A B C. A B C. Next one. A B C. A B C. I think this. 2 edges. Next one. All edges. All edges. A B C. So 1 edge 3 possible. 2 edges 3 possible. All edges 1 possible. No edge 1 more possible. Total 8. Right? Total is 8. So some people are asking, with n is equal to 3, all possible simple graphs are n is equal to 3. Possible simple graphs are is equal to 8. How? Right? I think you know very well is n is equal to 3. Right? maximum edges how many? Maximum edges. N is equal to 3, maximum edges possible. I think 3. 3 edges. For every edge, 2 choices. 3 edges. For every edge, 2 choices. Each edge, 2 choices. So 2 power 3. For each edge, 2 choices. 2 power 3, which is 8. Edge may be there, may not be there. Edge, 3 edges, na? Every edge having maybe, may not, 2 choices. So 2 power 3. Now, to get the more clarity. Thanks, I got analytics Suratkal CSE. Thank you. Congratulations. Congratulations. Dark side, congratulations. You can WhatsApp me. Dark side, you can WhatsApp me. This is my WhatsApp number. Dark side, this is my WhatsApp number. You can WhatsApp me. First of all, congratulations. Yeah, thank you so much. Thank you so much for informing. So maximum edges are 3 edges. Every edge having 2 choices, so 2 power 3. Some people are asking, sir, same story, n is equal to 4, how? N is equal to 4. So maximum edges are, first find out maximum edges. N is equal to 4, maximum edges, 4 into 3 by 2. 12 by 2, so 6. 6 edges maximum. N is equal to 4, maximum edges are 6 edges. Right? How many simple graphs possible? So 2 power 6 simple graph. For every edge, 2 choices. Now some people are asking, n is equal to n. Means n vertices, how many simple graphs possible? That is the given problem. N vertices, how many possible? First of all, find out. Maximum edges, how many? N into n minus 1 by 2. Means complete graph. Maximum edges are given. Next one. Maximum simple graphs possible. Maximum simple graphs possible. For every edge, 2 choices, na? 2 power n into n minus 1 by 2. So this is. Right, fine. Thanks everyone. I hope everyone got it. Thank you so much. See you in the next class with some more details. See you in the next class with some more details. Thanks everyone. Thank you. Thanks everyone. Thank you so much. See you in the next class. Fine. Thank you. So if anyone having any small doubt, if you want this note, if you want these notes, WhatsApp me. There's a WhatsApp number, right? I will give the notes to you. I will give the notes also. If you have any doubt, you can ping me. Thank you and see you in the next class.